Hello everyone, so today I'm going to show you how to draw an amino acid. If you remember what an amino acid is, or if you haven't learned before, well, there's about 20 of them. So, 20 amino acids. And this is one of the 4 biomolecules that you're going to learn about in biochemistry. What is a biomolecule? I'll show you. There's 4 of them. So, there's 4 of them, and one of them is the amino acid, right? The first one is, well, for all intents and purposes, actually I'll do it like that. For all intents and purposes, the first one is the amino acid. And I'll say slash protein. Why slash? Because proteins are built off of these amino acids which form out of these chains. Okay? So the second one is a carbohydrate. Okay? So we have our carb. Gotta have our carbohydrates. And they're basically like sugars. Those are the little units. Okay, and then the third one is what we call lipids. And lipids are basically what you would call fats, right? When you have your olive oil, you have a lot of fried chicken, you're getting a lot of lipids in your system, okay? And then the fourth one is what you would call nucleic acids. And this is the most, very scientific sounding name, but don't be fooled. It's not really that complicated because there's 2 that you really need to know, and one of them starts with a D, and one of them starts with an R. Can you guess what they are? If you can, then that's great, but if you can't, it's okay, because I'm going to go over them in another video. But those are the 4 groups, okay? Now, we're not going to be talking about all this today. What we're going to be talking about is the amino acids. But we're not going to just memorize all 20. That's stupid, okay? We have a life. What we're going to do is we're going to learn the backbone. I want you to be able to draw the backbone of an amino acid and figure out why the things like the charge matter, right? Okay, so the first thing is that we're going to draw a carbon, because carbon will be like central to our, you can say, hydrocarbon backbone, okay? Hydrocarbon means hydro, as in, well, there's a lot of hydrogens in this hydrocarbon, and then we have a carbon because carbon is pretty much usually central. Carbon can accept 4 bonds. It's a pretty useful molecule, and it always ends up staying neutral that way, right? So you've always seen this whole tetrahedral shape, right? Where they have the 100 and I think 106, 100 something, 0.5 whatever degrees bonds, right? They're pretty stable. So what we'll have is the carbon being at the center. Do it again right here. So we have carbon, and it's going to be attached to a hydrogen. Okay? Simple enough. That is literally our first part. Now we're going to have 2 other groups. Okay? Now bear with me. The second group, I'm marking it with green. That's going to start with an N, so that's what you call the amine group. Okay? The reason you call it an amine group is because, see these 2 H's right here? An amine group, I'm going to draw this a little better. An amine group, if you just see an amine group hanging around, floating in space, just chilling, it'll look like this. It'll have 3 H's, 3 hydrogens. That's an amine group, right? My apologies if I forgot to scroll down. But that's an amine group. And the thing is, this amine group is attached to a backbone, right? You see this whole backbone over here. So because it's attached to the backbone, well, we don't really need this whole hydrogen here. That bond is already attached to the carbon. So this is still an amine group. And I'm going to say it as many times as I need to, so we remember forever. This is, we're adding a C over here because we want to make a carboxylic group, okay? So a carboxylic acid. So we have this double bonded O, right? Double bond. So I'm going to draw it one more time so you remember. Double, as in 2, not 1, not 3, but as in 2 bonds. Okay? So we have a double bond oxygen, and then this one is a single bond, right? A single bond oxygen and a hydrogen attached to that single bond oxygen. Why does it attach a hydrogen to that single bonded oxygen? Well, because it doesn't have the double bond over here like this one to make the oxygen happy. So it needs a hydrogen over here. And yeah, like technically you can just draw that bond out here like that, right? But it's okay. We'll be happy if you just do this. So this whole group is a carboxylic acid group, okay? Now, the thing is, in terms of protonation and deprotonation, I'll zoom out a bit. So in terms of that, like, all this really means is that, so we'll have this whole thing here, and I'll draw it out one more time on black. So all it means is that we're gonna have this whole thing, and actually, let me draw it really nice so I don't feel bad. I'm kind of particular about bond angles, but anyway, so when we have this whole thing out here, right, laid out like that, what happens is sometimes you'll carry protons through hydrogens. You'll see it in chemistry all the time. If you took general chem, you'll know that protons, they don't just float around in space like how electrons do, right? They float around through hydrogens. Hydrogens carry them. So, you know, you'll often see these diagrams of, like, let's say, like you have a beaker or whatever, and then there's a lot of H pluses inside of them, right? Doesn't mean that you know, it doesn't mean that the protons are just floating like that, but what we're saying is that the overall positive charge is increased, right? So if we add let's say we added a hydrogen to this amine right here. Let's say we added a hydrogen, right? What happens is you're increasing the charge. So the overall charge over here for this group is gonna increase. That's the protonated form, because it's now become protonated when it wasn't originally, and it was already neutral, right? Now, what's the deproton? So this is the deprotonated form when it's NH2 for amine, right? Now, what's the deprotonated form for carboxylic acid? It's literally this right here. It's actually not what you have in front of you. It's this, because the carboxylic acid, it came with this hydrogen, right? Right? And obviously, if we followed the logic of the amine, we'd want to be like, okay, let's just add another hydrogen here, right? And then protonate that too, right? Well, we can't just go around protonating everything, because the thing is, this thing might not want to be protonated. Look, this oxygen, it can fit only one more bond, right? Because it has a lone pair right here, and it can only fit 2 other bonds. So one of the bonds is already taken, and then one of them is given to hydrogen. So that's basically 2, 4, 6, and then, sorry, there would be another lone pair here. So it has 2 lone pairs and then 2 bonds. It's already a full octet, right? So if you just tried adding another hydrogen, it goes beyond its valence shell. It can't really fulfill that. This oxygen over here, you can't add a proton because there's a double bond here. You need to break this double bond, and then you're basically breaking the nature of the amino acid. You can't you can't change the carboxylic acid, right? So the only thing you can do is deprotonate the carboxylic acid. So if you ever see a carboxylic acid, and they're usually written in this short form like that, right? You ever see a carboxylic acid, you're only going to be deprotonating them if they have the hydrogen. You can never take a carboxylic acid like that and then just add another hydrogen. It doesn't make sense, right? So it would end up becoming that. So we'll do literally that, and we're gonna put this oxygen right here, and put a negative sign to show that, whoops, to show that this has become deprotonated, right? This thing is still neutral, right? And if we want to protonate it, because this is its deprotonate form, we can't really deprotonate it even further. If we did, it wouldn't make sense, because again, just using that logic, there's 2 bonds, 4 electrons, so like, right, like 2, 4, and then I didn't draw it here, but it had 1 lone pair, because generally speaking, when there's 3 bonds and then 1 lone pair, it fulfills the whole formal charge. But like, in any case, so you'll just need to know that nitrogen will have 1 lone pair, right? So that's 2, 3, 4, 5, 6 electrons, right? Now, if we took 1 bond away, we're reducing it to 6 electrons, which is not really what it wants, right? We want an octet. So you can, however, add a hydrogen. And the reason why you can do this is because this lone pair would end up attaching to something else, which would be that hydrogen. And then that would end up causing it to have 1, 2, 3, and then 4 bonds, right? And that becomes a full octet. But remember, the formal charge number that nitrogen needs is technically 5. So because it's 1 below that, what ends up happening is you put this plus sign to show that it's in a positive charge. So you don't need to think about formal charges and all that if that confuses you. Easy way to remember, that's just explaining what's going on here. But really the easy way to remember is just this. There's 2 hydrogens always, and that's the deprotonated form. Then you would add 1, and that one would be protonated, because you'll know by the plus sign, right? Because it's already neutral. You don't even need formal charge if you literally think about it like a number line, right? 0 is neutral. There's no charge. It's not negative or positive. Then we'll add a 1, 2, and a 3, right? And then -1, -2, right? So if we're at 0, and then we went to, let's say we deprotonated it. So we're jumping down, we're hopping down to -1, and that's basically what this becomes. Let's say we went up 1. We added a proton. So now we're hopping up to +1, right? Because that's basically what this is, +1. So that's why in this case right here, we can put our positive. But, you know, you're not gonna, you don't need to get too alarmed by this whole thing. Just know what protonation is and deprotonation is and how to recognize it. So, in any case, this will be our backbone, and I'll put the H right here. So that's basically our backbone, right? Now, there's one thing missing that we didn't put. Because remember, carbon needs 4 bonds. So we have 1 here, 1, 2, 3. There's 1 missing, that's the 4th one. And this 4th one is a special one. This is the R group, right? What does R group means? That just literally means whatever is different that from the, you know, the whole backbone. So like in every of the in each of the 20 amino acids that you're gonna have to remember, they all have a completely different R group. That's like the side chain that's attached to the whole, you know, backbone. But the stuff that's not the R group, this whole thing, all this that we just drew, this is virtually the same for every amino acid. The only difference is that sometimes they might get protonated or deprotonated for each of the groups, but that's literally it. So that's all you have to know about amino acids. Okay, I went pretty in detail, and hopefully, if like, you know, you don't have to draw them perfectly, but at least hopefully you can just recognize them right away when you see them and save yourself some time. I hope this helped.